Mi nombre es Luis Murillo, formo parte del equipo de GeneXus y la idea de esta charla es un poco introducirlos en qué conceptos debemos manejar cuando queremos introducir todas estas técnicas de inteligencia artificial en un proyecto que yo desarrolle con GeneXus. Si se quiere, yo vengo a hacer un poco el malo de la película en el sentido de que transmitirle, señores, a ver, un barniz básico tenemos que tener sobre todos estos temas y sobre cómo funciona, porque nuestra misión como desarrolladores va a ser tratar de acercar todo esto a los usuarios finales que no tienen mucho conocimiento del negocio, pero no tienen ningún conocimiento de todas estas técnicas. Entonces, el otro día charlando con Nicolás, jugaba un poco Nicolás con el lema del evento. Hay gente que tiene the power of talking y hay gente que tiene the power of doing. Yo creo que para pasar de tener el the power of talking a tener el del power of doing, algo debemos de estudiar y debemos de poder transmitir con solidez los conceptos básicos a la gente a la cual vamos a tratar de convencer que estas tecnologías son útiles para su negocio. A modo de ejemplo, quería comentarle, estamos hablando de esto, yo participé en junio de este año del Sapphire, el evento mundial de SAP, y Bill McDermott, que es el CEO de SAP, introducía este tema de una manera que a mí me resultó bastante ilustrativa, y SAP en este año está poniendo mucho foco en decir que su estrategia es transformar la empresa en una empresa inteligente, de Intelligent Enterprise. Este concepto no es un concepto nuevo, es un concepto que James Bryan Quinn hace muchos años ya lo introdujo.
Adopted or had introduced, and it's now being adopted. What is the intelligent company? Well, this is a clear example. He said that he's a friend of Kasparov, and he met him, and he told him that what was most surprising for him in this hinge time, well, at a time when a computer won our best chess player, the interesting thing was not that the Deep Blue had won out, but to imagine a future when Kasparov was going to be able to play supported by Deep Blue. So that is human beings supported by artificial intelligence systems. So what we have to do is to take the business, to take up to the business all this low tech that we're going to learn. In fact, this means what we can do and what we can't do with all this. Eugenio has already mentioned this, but basically artificial intelligence can be divided into three subgroups. The first one is the generic artificial intelligence, and that is a very old concept. John McCarthy introduced it in 1956, and it referred to machines that could emulate the behavior of a human intelligence. Now, that's a very generic concept, but in 1980, Arthur Swammel introduced a concept of machine learning. And machine learning, it refers to algorithms that may have behaviors without being pre-programmed. So I can emulate artificial intelligence with hard coding. Can I? Well, yes. I can program all options, but that's not what machine learning is all about. The idea is to have behaviors based on rules to obtain results, and that were not pre-programmed. That is, they learn on the basis of historical data, and they obtain results with data that have not been included in their training. And then in 1986, Minna Ditchell introduced the concept of deep learning, and this refers to a special class of machine learning based on neural networks. Neural networks are networks simplifying any problem, where every node of the network is specialized in solving one specific problem. Now, the name of deep learning means that the network is deep. Now, why is it that this is the time to introduce this type of technologies now for our projects? Well, basically because of three things that acted together. The first one is the big data concept. Now we have sensors everywhere. We've got a large volume of data. We can make them work for us. In the second place, we have the enormous power of calculation in our multiple processors, GPUs, and so on. If we combine all that, supported by these new algorithms of deep learning and machine learning, which have proved to behave well, well, this is the right time to start putting all together and take them down to our business projects. So what is it that we have to do as GeneXus developers to introduce all that? Well, three things. In the first place, to introduce to the basis of all this question of artificial intelligence. In the second place, to think outside the box, that is to rethink business processes that we would solve traditionally and how these algorithms can help us. And lastly, what is it that GeneXus can facilitate? How can GeneXus facilitate our life? So what's the basis that we can have? Well, the first thing is to understand what the basic algorithms are to assist us around artificial intelligence, how we can understand the minimum jargon and technology used all around, to have a basic technology to face these projects, and to know the different platforms and alternatives that we've got around. In the first place, then, as a guideline, I mean, this is just a guideline or an index of the things that would be interesting if we could go deeper into theoretically be sound. As Eugenio said, machine learning algorithms are divided into supervised learning and unsupervised learning. Those algorithms of supervised learning are basically two. One is classification or regression, and unsupervised learning algorithms are clustering algorithms. Now, all these different classifications are based on a multiplicity of algorithms implementing these classifications. As Eugenio said, there are many providers that offer ready-made solutions, and each one of them choose one or some of these algorithms. So you have to choose among the various providers. This is one of the good news. This is good news, and also the competitive advantages of using GeneXus to be introducing this type of solutions. So in the first place, let's look into machine learning that is supervised. And so if we talk about supervised machine learning, we have to know two concepts for these algorithms. The first one has to do with labels, and the other one has to do with features. When we are training models to use supervised machine learning algorithms, what we've got is a group of features of the problem that I want to solve. So for instance, if I want to use spam detection algorithms, the attributes I've got is the title of the spam, when it was sent out, some words that are in the body of the mail, and what I would like to infer or detect is the characteristic or the label on the basis of the starting features, and I would like to identify the label whether the mail sent out is a spam or it is not. Another example is when I want to determine the price of a house. So the features at the outset are number of rooms, bedrooms, the geographical location, and the label I would like to infer is the price of the house. So this is done on the basis of models, and what models do is they generate these relations between labels and features. Then we come to the second element, and that's models. Models have got two stages. One is training in the life of the model, that is to provide on the basis of known data. I would like to indicate the labels or the results that I want features that have indicated are. And then the inference stage in the model is whenever I get data that is unknown or not pre-labeled, the model has the capacity to infer the label. In this case, I've got a model where I've got lots of data of houses, and I would like to have a model inferring the price. Now, on the basis of the label, at the training stage, I can put in the price to each one of them. That's the training stage of the model. Now, the inference stage is whenever I get data that hasn't been pre-labeled, the model that I've trained has the capacity to infer the label for this data, which was unknown. As we have seen in the classification models, in the supervised models, we've got two types. We've got regression models and classification models. Regression models basically allow me to determine, as I said, given a certain data, what is the precise value of a house, and the other one is given an image, it can infer whether it's a cat or a dog there. The other one gives me discrete values, the other one doesn't. As regards unsupervised learning, then the most supervised algorithms are clustering algorithms. Let's see how these linear regression models work. For instance, we know that at a higher temperature, or the higher the temperature, the more the crickets would sing. If I've got values of crickets according to the temperature, I will have this data dispersion. So what these models do in training is try to determine this line on whose basis it can solve pondering attributes, weighing attributes, the value of the temperature. If I've got a certain number of songs and I don't know, songs of crickets, and I don't know the temperature. So these models can determine this function. The determination of this function is trying to minimize the loss in the training process. For instance, I could obtain this graph here as a result of the temperature according to the crickets singing. But if we look at historical data, well, this function behaves very badly for lots of data. So this function seems to be working out much better. This is what algorithms, training algorithms of models do. They try to obtain these functions with the minimum loss on the basis of the data provided. Now, to that type of thing, then there are many steps that I must have into account when training them. It's quite deep, and I'm not going to go into that now, but what is the step in between training? I would give in more data, the learning rate between the stages and so on. The other algorithm has to do with classification. If I have to determine whether an email is a spam or not, well, if the algorithm is returning 0.3%, that's not spam. If it's returned by 0.9%, then most certainly that algorithm shows it's a spam. Now, what happens if it's 0.6%? Now, I'm not sure if that's a spam or not, and so classification algorithms are trying there to determine the threshold that I have to indicate thresholds to determine the various categories of the result obtained. And lastly, clustering algorithms. Given lots of data, they set up groups maximizing the similarities of the behaviors of the group and minimize the similarities among the various groups. So if I apply this type of algorithms, if I put it into practice, I can have results that allow me to classify certain data. If we look all that into a neural network, well, those cases that we've seen were simple because the dispersion of data allowed me to have quite a linear graph. But if the data dispersion is quite mixed, then it's not a linear problem, and here I won't be able to have a linear function on whose basis I could infer the result of the data. And that's where neural networks come into play. The blue circles would be the features, the green circle would be the inferred data. I can't solve this type of problem, but if I start including data or adding data, these are the neurons that resolve or know how to resolve a very specific situation or case. If I start adding linear layers that are hidden, they will allow me to accommodate that dispersion of data that isn't linear to obtain a result that would allow me to obtain a graph. And in between, I can introduce non-linear functions that are activation functions. For instance, if I've got that dispersion of data with a simple neural network, the only thing I could do is to have a linear function dividing data into two. But if I start adding hidden layers, I could obtain graphs that behave much better in terms of predicting data. And if I start activating non-linear or activation functions in between, I'll be able to have a hyperline whose function will allow me to determine whether a data belongs to a certain class or not. If I see this in a class or not. If I see this into action or inaction, if I'd like to determine whether a data is approaching one spiral or the other one, this is the way a neural network would work, so that I could determine data and I could have a linear function on whose basis I could determine all this. Now, how do we train these neural networks? It would be good to go deeper into it if you have time, but it's not necessary, in fact, to put this into practice. We getting closer to the good news I said I was going to give you at the end of my talk. When we talk about neural networks, we're not talking about something very complicated. For instance, for this talk, I trained a model that, given a model, I try to define whether the image belonged to a superhero called Flash or not. So the only thing I had to do was to open two folders. I would put a folder with lots of images that contain Flash. The other one didn't. And so I trained the model. Obviously, for the volume of data, I did it as an example for this talk. But here we can see that the first values are when I had very few images on the left. The image on the left, well, it made mistakes. And when I put the image, it said that it was Flash, but it wasn't. When I started introducing more and more examples, spirals started getting separated, and so the model was able to differentiate better which image was Flash and which one wasn't.
Cuando yo entreno estos modelos de esta forma,
when I train models in this way, is I get a file, which is a standard in our industry. It's a PB extension. It's protocol buffer. And I can take that model anywhere and start using it to obtain results. That is, I can infer it by using that pre-trained model. As you can see in the training process of any model, we can see two stages. One is training and test sets, and the other one is the validation stage. And we have to take all that into account when we carry out these projects. In general, the group of data that we have to use is to divide it into 80% for training and 20% for tests. And in the 80% of training, it's good to divide it into a 20% for validation. So I would run several validation processes, and once I've got the model and I consider it behaves well, I can test it against the 20% and I can get my results. Now, Now, all those data that I placed in my example in those two folders, I must also take some things into account regarding the data. If I put the same image to train, saying that that is flash, and the same image saying it's not, well, that's not interesting. It's good that they are dispersed. So there are 4 basic steps to train a model. The first one involves the dirty values. The other one is to handle extreme outliers. If I get training values and, for instance, the number of bedrooms in a house, there are many data telling me that there are many cases where most houses have 1 or 2 bedrooms, and then suddenly there is one with 50 rooms. Well, that would be a very typical house. So the idea is to form groups in values. If I've got the geographical position or situation of a location of a house, then I could set up ranks for those values, and then cleaning dirty or wrong data. To do this, there are several methodologies in place. We recommend and use one called CRISP-DM. That's the one we've used, or I've used in internal projects. This refers to how to gather data, how to clean them, etc. In the second place, and we're getting closer to the good news I've told you about. As we said, all these algorithms, if they are very complex problems, then I've got to go through all this process. But if problems are simpler, then the large players in the industry, as Eugenio said, Google, SAP, IBM, Amazon, and so on, from Far East, provide us with pre-trained models that we can very easily use and put them into practice. So what we have to do is to set up a team managing these topics, know about the business, where we're going to apply it, and we have to find allies in companies knowing the business and trying to approach the two parties. Of course, we have to get the data, that's fundamental, and we have to know what we can do with GeneXus and start testing. And since there are many players that have encapsulated all this, offering different solutions, this is a very good piece of news about GeneXus. When there are many options, it's good to use GeneXus, because with a common language will allow us to be able to choose the provider that, for the case I want to implement, will behave the best. This is very similar to a database. To make a development with GeneXus, I needn't know what a database is and how it's going to normalize. It's GeneXus is going to solve it. Now, it's good that you know the basis of all these concepts. And since there are many providers offering database managers, if I use GeneXus, then I no longer have to choose a supplier of database. This is the same thing. It's good that I know the base of artificial intelligence, but since GeneXus has built in all this knowledge, I only have to have one first approach to the topic. Since there are many providers in the world, I won't have to be testing each one of them and reprogram them if the provider is not behaving in the way I want it. I just take GeneXus and I choose the supplier of the solution I want to have. So what I was saying is that our team must have a developer and someone on the user side to know about the business. Data analysts will be needed only in case the complex is very complex. And lastly, what have we got in GeneXus to help you out? Well, as Eugenio said, we have the chatbot generators, all the different generators, and also the AI module in GeneXus. And what we've done is to divide the problems in 3 branches. One is audio, the other one is image, and the other one is text management. So what the only thing I do is I use the primitive things that GeneXus gives me and link a provider, a supplier, offer me pre-trained models. I can check and test how they behave, each one of them, and the best one is the one I'll select. Now, there are many AI problems that are very complex, but there are others that are quite simple and that we can start using in our solutions. One of them will be seen in our lab of artificial intelligence. We'll be able to develop an app given a text, whether it can translate it or voice it. What is written can be read out. Those are very specific solutions that you can include in your development. And this means that you are introducing artificial intelligence in your GeneXus developments. In the case of our framework in GeneXus for SAP Leonardo, is the one that you can check how it's been developed. And it's just that. It's using a call to the APIs, networks. In this case, it's SAP Leonardo. And we have 8 examples. One is OCR, allowing us to recognize characters. It recognizes characters when the image hasn't got much noise, when it's quite clean. And then we have syntax, that is to recognize a text, an image with a little bit more with more noise. I would be able to use this surface and it'd be able to detect the text in the image. The third one is image classification. Given an image, it would classify it in certain categories that were pre-trained for this model. And these are the pre-trained models. If I wanted to have my own private categories, then I would have to train a model. But there are many, many models that are already offering me pre-trained categories. And this is an example of it. The second thing is image similarity. There are 2 images, and it tells me what the similarities are. The next one is product text classification. It classifies a product on the basis of the description. And it will tell me to what category of these pre-trained categories it belongs. The next one is face recognition. Given an image, the system detects the faces. And the last one is detection of language. And lastly, translation. Given a text, it will translate it to the language I've indicated. Now, this type of solutions, just by using GeneXus, and there'd be no need to have hard knowledge of AI, can be introduced into your systems. However, if you have a client that needs to go deeper or needs to have a specifically trained model, then we have the GeneXus Co-Innovation Lab. There we can help you to carry out this project supported by GeneXus. And anything that we can train externally, we can also support you if we are interested. Please get up to us, come up to us and tell us about your projects. So what I said, what we have to do is to think outside the box, out of the box, to see how we can introduce these things in our developments. We have to use GeneXus and do it. It's the power of doing. That is all. Thank you.